All right, here are solutions for our first quiz for Math 111. Two questions, both about circles. First one, it says, I drew a circle that was centered at -8, 5 and passed through this point right here. So what it wants to know is what's the standard form of the equation of this circle? Well, the standard form of the equation of a circle centered at A, comma B with radius r is this guy right here. So really what I got to figure out is what is A, what is B, and what is r, and then that'll be my answer. The good news is two of those things are given to you in the problem. It says it's centered at -8, 5. So as long as you recognize that A and B are the x and y coordinates of the center respectively, all you got to do is change the A into a -8 and the B into a 5. In other words, x minus -8. Sure, I'll write it. And then y minus 5. The radius is not quite so easy. The way you have to figure out the radius is note that it's not given in the problem. But there is some extra information. It tells us that the circle passes through this point -2, -3. So since the radius is defined to be the distance from the center to any point on the circle, and I have the center of the circle and I have a point on the circle, if I could just figure out the distance between those 2 points, I'd know the radius. So maybe off to the side here, I'll say, well, I got this formula for distance. This is my distance formula. It tells me that the distance between points x1, y1, and x2, y2 is the square root of the sum of the squares of the difference in the x and y coordinates. It's kind of a mouthful, so it's easier to just write it out. It's this thing right here. So I arbitrarily call, I don't know, maybe this is x1, y1, x2, y2. And I can say that the distance between those points, aka the radius, is, I guess, x2 would be -8 minus, sorry, I wrote -8 and said -2. x2 would be -2. x1 would be -8 if I decided, I'm going to write it. You can call these whatever you want, but let's just say I decided arbitrarily to name them this way. Then x2 minus x1 is -2 minus -8, in other words, y2 is -3 minus y1, which is 5. And so that I get the distance between these 2 points is, well, let's say -2 plus 8 is +6. And -3 minus 5 is -8. So whatever 6 squared plus -8 squared is, well, let's see, 6 squared is 36, and -8 squared is +64. And if you add those up, you get 100, and the square root of 100 is just 10. So the distance between these points is just 10, so what that tells you is that the radius here is also 10. This 10 sort of becomes this 10. But be careful, on the right-hand side of the equation, we got r squared. We don't have r. R is equal to 10. The radius is 10. I want r squared. If you left your answer like this, it would be fine, but I don't like leaving the minus and negative thing. I just think that's ugly. So I'll make it x plus 8 squared, y minus 5 squared equals 10 squared or 100, whatever you want. Call this right here the answer. Okay, number 2. Kind of working backwards here. In this one, we were told a bunch of information about the circle and asked to come up with the standard form. In this one, we're kind of given the equation of the circle and told to come up with information about it, like the radius and the center. The problem is you can't come up with that just from staring at this guy. Actually, you might be able to come up with some of it just from staring at this guy. But what the problem tells you to do is first express it in standard form. So do something algebraically so that this looks something like this. And that something you do is called completing the square. So I'm going to rewrite this as x squared plus 6x plus y squared minus 8y. Just reordering these first 4 terms so that my x's are together and my y's are together. And then I got this plus 16, which I don't want to be on the left-hand side, so I'm going to subtract 16 from both sides of the equation to give me minus 16 here. And on this next line, I'm going to note that I do not have a perfect square right here regarding my x's. I don't have a perfect square. X squared plus 6x is not a perfect square, but there is some number that if it were written right here would make this a perfect square. What is that number? Turns out that number is 9. I'll explain in a minute how I came up with that. Similarly over here, well, let's explain how I got it. Probably the easiest way to come up with it is defining b to be the coefficient on your x term. So in this case, b is equal to 6. The number that you add to both sides of the equation will always be half of b squared. So half of 6 is 3, 3 squared is 9. So it's 9 that I add to both sides of the equation. Over here, my b would be negative 8. Half of negative 8 is negative 4. Negative 4 squared, positive 16. So I'm going to add 16 to both sides of the equation. Now what I have is a perfect square here and a perfect square here. I recognize that this is x plus 3 squared. If you recognize this is x plus 3 squared, great. Then you can tune me out for a couple seconds. If you don't, there's a little hint on getting from here to here. And what it is that this perfect square will always take the form x plus b over 2. So way up here when we decided b was 6, we knew that this was going to be x plus 3. X plus whatever half of this number is. Squared. So I got x plus 3 squared on this side. What about on this side? Well, my value of b was equal to negative 8. So this should be a perfect square of the form y plus half of b, b over 2. b is negative 8, so half of negative 8 is negative 4. Y plus negative 4 squared. And it is. Y minus 4 squared is the same as this. Try it. Expand this out. Y minus 4 times y minus 4, FOIL. You'll get this right here. And over here, negative 16 plus 16 is 0. Plus 9 more gives me 9. Get to here. From this, you can deduce that you have a center at negative 3, positive 4. Careful, it's tempting to think it's positive 3, negative 4. It's not. It's negative 3, positive 4 because this is our standard form of a circle centered at AB. Note we got these negative signs. So if the center of the circle is at negative 3, 4, I would get x minus negative 3. In other words, x plus 3. Radius, tempting to call it 9, it's not. The radius is 3. The reason it's 3 is because this thing right here, this number, is equal to r squared. Maybe I'll write that down. 9 equals r squared, so r equals 3. I guess the answer to the question, what is the center, what is the radius? It's this guy here. And what is the standard form? That's this guy here. And if you decide to leave this as 3 squared, that's fine too. I don't care what you do. And that's it. That's the end of this quiz, so I'll stop this video there.